Hi, we're going to work our way into solving by completing the square and the quadratic formula. But in these instances, we can get negative signs under the radical, and so we have to learn how to handle that. So we're going to talk about the imaginary number I. We're going to talk about how to multiply square roots of negative numbers, and we're going to talk about how to divide square roots of negative numbers. Let's talk about the new number, imaginary I. It is part of the complex numbers. The complex numbers include all of the reals and the imaginaries. So if you think of it as an umbrella, complex is the outer, and it has imaginary numbers, and it has real numbers. The reals we've already talked about. Now we're going to talk about the imaginaries. The definition of an imaginary number is the value I equals the square root of -1, which means that if I were to square both sides of the equal sign, I would get I squared equals -1. Whenever you square a radical, you get whatever is underneath that radical. This is a very important number because it comes up a lot, and we always want to know how to simplify that I squared equals -1. To simplify the square root of a negative real number, what we're going to do is we're going to first see what it looks like. We would have a negative under the radical sign, like this. The next thing that we're going to do is we're going to split it into -1 times b. Then we're going to break up our radical into two radicals, the square root of -1 times the square root of b. We're going to simplify the square root of -1 as I. And then we'll simplify the square root of b by taking out all the perfect squares using prime factoring. Okay. As a rule, i's always are placed in front of the radical sign, but behind coefficients. And behind coefficients. So if we're going to simplify the square root of -1, I can't make those circular times symbols, so I'm going to use parentheses. We're going to rewrite this as -1 times 100. Then we're going to split it into two pieces. This is the square root of -1, and then the square root of 100. The square root of -1 is I. The square root of 100 is 10. These are being multiplied together. So we just place the coefficient in front of the I, and we get 10I. And this is our final answer. I. Letter B is similar, but notice that I have that negative out in front. This does not change to an I. It stays just as it is. It's this one underneath that gets pulled out as an I. So this becomes negative, and then I have, or stays negative, then I have -1 times 36. Then I write this as the square root of -1 times the square root of 36. And then I have I times 6, so I get negative 6I. And this is my final answer. If you're noticing, the negative just comes out and then we simplify the radical like we're used to doing way back from Math 7, pre-algebra. Okay, the square root of negative 2, the negative comes out as an I, and then we're left with the square root of 2, I root 2. The square root of negative 54, the negative comes out as an I. The square root of 54 gets simplified. Start dividing by primes, 3 and 18, and 3 and 6, and 3 and 2. That's prime factoring. The doubles come out as a single. So I have 3 times I times the square root of 3 times 2, which is 6, right? Now we're going to multiply negative square roots together, and the key thing to remember is pull the I out before you do any multiplication. Then multiply the square roots together and simplify, multiply the i's together and simplify. Simplifying the square roots means finding all the perfects or prime factoring techniques. Simplifying the imaginary means using the pattern of I, where I squared is equal to negative 1, I cubed is equal to negative I, and I to the fourth is equal to 1. So the first thing that I do is I take my i's out first. So I have I times the square root of 3. And then I have times I times the square root of 7. I times I is I squared. Square root of 3 times the square root of 7 is the square root of 21. That cannot be simplified. I squared can be simplified. What does I squared equal? Well, that always simplifies to negative 1 times the square root of 21, which equals negative square root 21. B, I'm going to pull out the I, and I get the square root of 4 times I times the square root of 9. These are both perfects. So this is 2I times 3I, which equals 6I squared. What does I squared equal? I squared always equals, I know it sounds weird, negative 1. So this is 6 times negative 1. So that's negative 6. Some of this you're just going to have to accept to begin with till you get used to it, and then it all starts kind of clicking. I'm going to simplify negative square root of 2. That becomes I times the square root of 2 times I times the square root of 8 gives me I squared times the square root of 16. I squared becomes negative 1. The square root of 16 becomes 4. So I get negative 4. The square root of negative 5 times the square root of 6. I take my I out, so I get I times the square root of 5 times the square root of 6. This is prime. This is a composite, but it is not factorable. So we get I times the square root of 30. My I doesn't cancel with anything. I can't simplify it. It's just I root 30. Now when we divide square roots, again, you want to pull out your i's first and cancel where you can, and then simplify the radicals. Okay? So my numerator becomes I times the square root of 75. My denominator becomes I times the square root of 3. These cancel. Since 3 goes evenly into 75, this becomes the square root of 25 because I just divide them, and then I get 5. 5 is my final answer. The i's both canceled. I'm going to take out my I here, so I get I times the square root of 32 divided by the square root of 9 is 3. Now I'm going to simplify the square root of 32. So I have, I'm going to go over here to 32, and I'm going to use prime factoring, and I'm going to divide by 2, and I get 16, and I see that that's 4 and 4. 16 is a perfect, so I have a pair. So I get, going down here, I get 4i times the square root of 2 over 3. And that's as simple as it gets. All right, go ahead and watch the next video about simplifying higher powers of I.